Welcome back to Wickerson Studios. I am returning to some exciting books on actually algorithms in ghpython. And what I'm going to do in ghpython in Grasshopper 1 is I'm going to bring back the ghpython remote node. And I'm going to show a tutorial how to hook that up. But right now, before I need the ghpython remote, which will allow me to use Numpy and Pandas and all the wonderful stuff that people really get excited about, and the reason you can actually start looking at algorithms, um, uh, you're going to need access to those libraries through Grasshopper. And even though I've had some conversations with people questioning why I would choose to do that in Grasshopper, I think there's been a call for it, so I'm going to continue with it. What I have here is basically a section of the chapter that doesn't need the ghpython remote to start with. One second. Okay. Just had a little noise there. Basically, what I have here is explaining recursion, which is usually enough to draw somebody into why you would want to use the ghpython function. In recursion, you call a ghpython, it does something, and then it calls itself repeatedly until it reaches a specific condition. But all those previous calls are still active. The call unwinds themselves one at a time until the first call finally ends with the correct answer. And this unwinding process is where most people encounter a problem. Now, the trick is you're trying to visualize what's happening. What's nice here is the script here, unlike using the factorial node, which comes with Grasshopper, you can write your own script over here that will actually process and show you exactly what's happening. So the first section, because I've added this A on here, I guess I could comment this out to start with. I have to think of my hashtags because I've used the C#. Let's comment that out and run that script again. And you'll see that it's just running that first half in the print line. And it's calling factorial called with n3, then with 2, then with 1, and then the ending condition is met, and you're left with that output, which is the factorial of 3. You can extend that up and see those numbers climb. So very nice. The conditions for ending recursion haven't been met, so the function may call itself again, or the conditions for ending recursion have been met, so the function returns a final value that is used to calculate the ending results. Now, I'm getting all this data from John Paul Mullers and Luca Massaran's Dummies book for algorithms, and I'm going to go through that text, but it's a wonderful way to get using ghpython when you do it. So it's important to realize that there isn't just one method for using recursion. If anybody plays the Python sites for learning how to kind of program, solve, and learn your own programming. But I'm going to pull up another file here, which is another way to write the same program. Here's another version of factorial recursion with fewer lines of code. And if we take a look in this one, basically it's got the print call, which will it will call this number. It comes up exactly. It will call with the number smaller and smaller until the ending condition was met, and then it will output that result. And so it's got a few less lines of code, but it's a little harder to understand what's actually or visualize what's happening there. The next example in the text, which is wonderful, is you may want to eliminate what's called tail call recursion because it consumes memory. You can eliminate tail calls from your recursive routines. The simplest approach is to take is when you want to eliminate recursion is create an iterative alternative. A while loop replaces the recursive call, but you still need to check for the same condition and continue looping until that data condition is met. And there you go, another fine call of that, which goes in, it writes a definition factorial, and then it brings out, calls the while loop, and then returns the result when you're done. And you can just run that function as many times as you like. So that's a nice little introduction to getting back into algorithms. A lot in this text can be done without ghpython remote, but I think it's going to be essential for dealing with multiple arrays and doing more with Grasshopper that maybe somebody wants to do. So hopefully people will follow this. They'll be excited about it. I'll get a few comments, and I'll be passionate about continuing this. Obviously, I have tons and tons of playlists. I go wherever interest is, and I do that for a temporal time until people kind of lose interest or more people gain interest. But ghpython has been one of my biggest, fastest growing groups, and I haven't been doing any Python for a year since last summer. So I think I'm going to go back into it. Anyhow, thanks for watching. Michael at Wickerson Studios will be taking a look at ghpython remote, getting it up and running in Grasshopper 1, and seeing where that goes.